Okay, in this lesson we're going to continue with Unit 6, Chapter 6, Trigonometric Identities. We're going to continue with Proving Identities Part 3. And we're going to look specifically at proving identities that involve conjugates. So as I said, this is from Section 6.3 in your text. And again, we're going to be proving some identities using conjugates. Here again are your formulas that you need to know. Your double angle identities, your difference identities, your sum identities, and again here are your Pythagorean identities as well. All of these that you see here will be given to you on your exam. You may need to use these as you use conjugates as well. You may not, but you may as well. So I just drew them here on your slide just in case. Okay, let's look at a few examples that involve identities. Prove the identity 1 minus cosine x over sine x equals sine x over 1 plus cosine x. Okay, what we're going to do here, if you look at this one, you can see that there's not a lot we can do with it from initially looking at it, because everything is already written in terms of sine and cosine. I can't replace anything here in terms of a double angle formula or a sum identity or a difference identity. So there's not a whole lot, initially it looks like there's not a whole lot I can do with this. But what I can do is I can take the left side of the equation. Let's start with the left side here, and let's work from here. 1 minus cosine x over sine x. And I'm going to multiply the left side by the conjugate of 1 minus cosine x. And there's a reason why we do that, you'll see shortly. If I multiply by the conjugate being 1 plus cosine x over 1 plus cosine x, you will see that in the numerator you will get 1 minus cosine times 1 plus cosine. You should recognize that as 1 minus cosine squared over sine x times 1 plus cosine x. Again, all we did is multiplied 1 minus cosine times 1 plus cosine. You think of that, 1 times 1 is 1. I got a minus cosine and a plus cosine. They're going to cancel. And I got a minus cosine squared. And the reason why I do that, of course, you should be able to see now that my numerator is 1 minus cosine squared. 1 minus cosine squared is a Pythagorean identity is equal to sine squared. So I can rewrite that as sine squared over sine x times 1 plus cosine x. Of course, now we can cancel a sine x in the numerator with a sine x in the denominator. And that will leave us with a sine x in the numerator. So it becomes sine x over 1 plus cosine x. And if you look at your right-hand side, that's exactly what we have. So I've proven the identity pretty simply by multiplying numerator and denominator by the conjugate of 1 minus cosine. That's what I did there. Okay, next example. Again, if you look at the left side of the equation here, not a whole lot I can do with that. I may work with that afterwards, but let's start with the right side of the equation. It's the one that you would probably start with here. So with the right side of the equation, if you look at your numerator there, you should see that in the numerator, I can remove a secant x as a common factor. Let's do that. So I'll remove secant x instead of 1 minus sine x over cosine x. Now we need to do a little bit of simplifying here. Secant is 1 over cosine times 1 minus sine. I'm not sure where that negative one comes from. Let me get rid of that. Here we go. Let me just fix that again. 1 subtract sine. Now that's divided by cosine. Agreed? So I took my numerator, which is 1 over cosine, times 1 minus sine, divided by cosine. I'm not going to multiply the 1 over cosine in through. I'm going to leave that as it is for now. You'll see why. So I get 1 over cosine x times 1 minus sine x multiplied by 1 over cosine. Because we take the reciprocal, of course, of cosine. When we multiply all that together, I get a numerator of 1 minus cosine, 1 minus sine over cosine squared. So I get 1 minus sine over cosine squared. I want to get 1 plus sine x, which is on the left-hand side. Now I can start working with the left-hand side here. Or I could replace my cosine squared with something. But I think what I'll do is I'll work with my left-hand side. Let's work with the left-hand side and see if we can get to the right-hand side. There's a couple of ways we can do it from here. I could actually replace cosine squared with 1 minus sine squared and factor it. And I would get this. But that way I wouldn't be multiplying by the conjugate. Since we're dealing with conjugates, let's do it by involving conjugates. So let's take our left-hand side, which is 1 over 1 plus sine x, and let's multiply that by the conjugate of 1 minus sine over 1 minus sine. So there's oftentimes more than one way to do these. So my left-hand side becomes 1 minus sine x over my denominator in this case, you can see is going to be 1 plus sine. I'm going to leave it like that for now, over 1 plus sine. Sorry, 1 minus sine. Now, if we multiply the denominators together, we're going to end up with 1 minus sine x in the numerator. If you multiply your denominator, 1 times 1 is 1. You got a minus sine x and a plus sine x, they'll cancel. And I got to subtract sine squared x. Now, if I replace the 1 minus sine squared in the denominator, you should recognize that as an identity. It's cosine squared. And you can now see that my left-hand side and my right-hand side are both equal. Right-hand side is 1 minus sine over cosine squared. Left-hand side is 1 minus sine over cosine squared. So I work with both sides of the equation this time until I got them both equal. It's example 2. Example 3 is this one here. Again, I'm probably going to have to work with both sides of the equation here. Okay. Although we may not. Let's see. Let's start with the left-hand side, shall we? I got sine x times cosine x over 1 plus cosine x. Again, everything is already in terms of sine and cosine. So we're not going to be able to change anything back there. All I can really do with this is multiply this by 1 minus cosine x over 1 minus cosine x. There's your conjugate again. And the reason we do that, again, is because we're going to get a nice denominator down. And you'll see why. Let's leave the numerator as sine x times cosine x times 1 minus cosine x. We're not going to multiply that in true. We're going to leave it as it is. Your denominator, again, becomes 1 subtract cosine squared. And again, you see why we did this, because 1 subtract cosine squared is sine squared. So I got sine x times cosine x inside of 1 minus cosine x over sine squared x. And now you can probably see why I didn't want to multiply this in true, because now I can cancel a sine x with a sine x here. And when I do that, I'm going to be left with cosine x inside of 1 minus cosine over sine. Now let's see if we can get the exact same thing to occur on the right-hand side. The right-hand side of the equation is 1 minus cosine over tan. Now tan is sine over cosine. So let's simplify that. I get 1 minus cosine x divided by sine x over cosine x. Just rewriting it, of course, by taking my division line and rewriting it with a division sign. And now I want to multiply by conjugate. And again, while you're doing this, you should always be looking at the other side of the equation, what you're trying to get. And if you look closely, it's exactly what I have. I got 1 minus cosine times cosine, or in other words, cosine times 1 minus cosine, over 1 times sine, which is sine. So again, you see that the left-hand side of the equation does equal the right-hand side of the equation. Let me just try and make this a little better here. There you go. So that proves that identity. I think we have one more example to do. It's example 4. Now then, let's again work with one side or the other. We'll probably start with, let's start with the left-hand side. I got 3 sine x over 1 minus cosine x. Again, this is the left-hand side. If I multiply that by 1 plus cosine over 1 plus cosine, again, multiplying by the conjugate, that's what we're doing here, I get 3 sine x times 1 plus cosine x. And we're going to leave that as it is. We're not going to multiply it in through. And we're going to get 1 minus cosine squared. And hopefully you again see why we did this. Because now we have 3 sine x times 1 plus cosine x over 1 minus cosine squared, which is sine squared. Here's your identity again. And again, we can cancel a sine x with a sine squared x to leave us with a sine x in the denominator. So I'm left with 3 outside of 1 plus cosine over sine. And I'm going to leave it like that for now, for the left-hand side. Now let's work with our right-hand side and see if we can get it equal to that. The right-hand side, if we remove a common factor of 3, I'll have 3 outside of cosecant x plus cotangent x. Let's simplify that by rewriting cosecant as 1 over sine, and let's write cotangent as cosine over sine. So cosine x over sine x. If I simplify what's inside the brackets, I got a common denominator of sine x. I got a 1 plus cosine x in the numerator. If I multiply to 3, this is really 3 over 1, of course. So if you look at, again, the left-hand side, what I have over here, you see I got this done. Because it's 3 times 1 plus cosine x over sine x. So I've worked with both sides of the equation again, and I did manage to get both sides to be the same thing. So we're done. Again, each of those examples involve multiplying by the conjugate. So again, some strategies that may help you prove identities include, and as usual, use known identities to make substitutions. We did that a number of times. And multiply a numerator and denominator by the conjugate of the expression, which is what the entire lesson was all about. And that ends this lesson.